In this video, we will introduce to you the Interactive Parallelization Tool, or IPT for short. We will cover what IPT is, who it is for, and how it can be used. To provide some context, what is a serial program? A serial program is a software application that runs using only one core of a processor. On the other hand, parallel programming typically involves breaking down large and complex computations into smaller pieces and running these pieces simultaneously on multiple cores or processors to reduce the time to results. It is critical for efficiently using not only the current and future generation supercomputers, but also the commodity computers equipped with many-core and multi-core processors. Typically, existing serial programs serve as a starting point for parallelization. The serial programs are re-engineered to produce the parallel versions. Developing efficient parallel programs for different hardware platforms can be a challenging task. It requires the knowledge of parallel programming concepts, hardware architecture, and the syntax of parallel programming paradigms that are relevant to the chosen hardware architectures. It may also involve manual code reengineering. Additionally, there are no set rules or guidelines for efficient parallelization. Some trial and error may be involved in the process. Troubleshooting the errors in parallel programs can also be difficult, as the error messages are typically not very descriptive. Incorrect parallel programs can crash, deadlock, or suffer from race conditions without providing any helpful information to the developers. These challenges motivated the development of the Interactive Parallelization Tool. IPT is a high productivity tool that can semi-automatically parallelize serial C and C++ programs. It solicits the specifications for parallelization from the users, such as what to parallelize and where. On the basis of these specifications, IPT translates the serial programs into working parallel versions using one of the three popular parallel programming paradigms, which are MPI, OpenMP, and CUDA. Hence, IPT can free the users from the burden of learning the syntax of the different parallel programming paradigms, and any manual re-engineering required for parallelizing the existing serial programs. IPT can be used to parallelize applications from multiple domains, but currently it is mainly being used for educational purposes. For the test cases that we've considered so far, the performance of the parallel versions generated using IPT is within 10% of the performance of the best handwritten parallel versions available to us.